Hi guys, this is PreCalculus Final Exam A. We are in video 3. Hopefully we can finish this one up, but we'll see. Alright, so we want to figure out which of the following intervals represents the solution set to the inequality, and we got this rational function is greater than 3. And I'm going to do this by graphing. So first I'm going to think about how do I graph this guy here. So I know for this guy here I've got a vertical asymptote at x equals -4. For my horizontal asymptote, the degree of the numerator is equal to the degree of the denominator. So y is going to be equal to the leading coefficient of the numerator divided by the leading coefficient of the denominator. So 1 divided by 1 would be 1. To find the x-intercept, I'm going to set this guy equal to 0, which means this numerator has to be 0. When I solve that, I get x is equal to 1. When x is 1, we said y was 0. All right, to find my y-intercept, we're going to plug in 0 for x. So we know x is 0 at the y-intercept. Plugging in 0 for x, those guys go away and I get -1, 4. All right, let's see if we have enough to graph just the left-hand side of this equation over here. Vertical asymptote at -1, 2, 3, 4. Horizontal asymptote at 1. And we know I've got a point at 1, 0, and down here. And I know rational functions make a shape like that. Now, that's a great graph, but we want to know when is this graph greater than 3. So here's 1, 2, 3. I want to know when is it above the black line there. In order to find this point, I want to know when do those two equations equal each other. So when does x minus 1 over x plus 4 equal 3? To solve this guy, I'm going to multiply by x plus 4. We get 3 times x equals 4. Bring that over here. I've got x minus 1 is equal to 3x. 3 times 4 is 12. Subtracting x, I get 2x. Subtracting 12, -12 minus 1 is -13. Divided by 2 is, hold on, don't catch up. Give me a second. There it is. -13/2. So I know at this point, x is -13/2. And then I want everything that's greater than this line here. So from -13/2 to my asymptote, which is at 4. And that's going to be represented by C, from -13/2 to -4. All right, find the range of this function here. I love these finals because it's taking all that math that we learned and like putting it all together. And it's really good stuff. Hopefully you remember this part because we just did this one. So this graph is getting, I'm not too worried about the horizontal changes. Why not? Because I'm worried about the range. Range is just my changes in y. So my first change in y is we're shifting this whole graph down 4. 1, 2, 3, 4. So here's my midline, right? My intercept line. We know from that midline we're going up 5 and down 5 because the amplitude is 5. So 1, 2, 3, 4. One more will give me 5. That's going to be the high point of this graph here. And then going down 5, 1, 2, 3, 4, 5. That's the minimum point for the graph. So my sign is going to oscillate somehow in between those two. That's a really bad sign graph because I know it's supposed to go through here. But it may not because of all this stuff going on. But what we do know is the high point is 1, the low point is -4 minus 5, which is -9. So my range is going to be between -1 and +9, -9 and +1. All right, 22. Suppose that sine theta is 2/5 and theta is in quadrant 2. So we're in quadrant 2. We know sine, which is opposite over hypotenuse, is 2/5. And we want to find cosine. Well, cosine is adjacent over hypotenuse, so I've got to figure out what this guy is here. To find that guy, that's using the Pythagorean theorem, x squared plus 2 squared is equal to 5 squared, which means x squared plus 4 is equal to 25. Subtracting off the 4, x squared is equal to 21, x is equal to plus or minus the square root of 21. But we know we're in quadrant 4, so what does x have to be, positive or negative? Hopefully you're screaming at the computer, negative square root of 21, Miss Harris, which means my cosine, which is adjacent over hypotenuse, is negative 21/5. Oops, which is C. 24. First I'm going to find f of 2 plus h, which means everywhere I see x in this equation, I'm going to put 2 plus h. And then I'm going to go ahead and multiply this out, see what we've got. So 2 plus h times 2 plus h would be 2 plus h squared. 2 times 2 is 4. 2h plus 2h is 4h. H times h is h squared. Plus 2 times 2 is 4. Plus 2h plus 1. And so this will be h squared. 4h plus 2h is 6h. 4 plus 4 is 8 plus 1 is 9. So that was just finding this piece. I still need to find f of 2 and then subtract those guys and divide by h. So f of 2 would be 2 squared plus 2 times 2 minus 1, that's 4 plus 4 minus 1, 8 minus 1 is 7. So now I'm going to put it all together. F of 2 plus h is h squared. Sorry. I think we're good. All right, so I got h squared. My brain is sitting here, sorry. 4h plus 2h is 6h. I know you guys think I've lost my mind. Oh, and then we said plus 9. And then minus f of 2, which is 7, all over h, which would be this guy. I've done something wrong. I'm trying to figure out rapidly because this is a video. All right. 2 times 2 is 4. 2h plus 2h would be 4h. h squared. 2 times 2 is 4. 2 times 2h is 2h plus 1. And then I've got 4 plus 4. Oh, here's my problem. This is supposed to be minus 1 right here. Sorry, I know you're screaming at the computer and you're mad, and it's probably not going to end up being all over one video now, so now I'm mad because I don't know how. All right, here we go. Sorry about that. I knew there was something wrong because the 7 minus 7 is supposed to cancel out, which now it obviously does because I fixed my mistake. And I can divide off an h. So if I factor out the h, I get h plus 6 on the top, h on the bottom, and I end up with h plus 6, which is A. All right, find the exact value of cotangent -1. I'm going to say, omit this problem. We did not do cotangent inverse. We only did sine, cosine, and tangent inverse, so we're not going to worry about number 25. All right, 26. Find the inverse of this function. We didn't do this per se in class, but you totally should be able to do this. We know for inverse functions, we switch our sign, our range, and our domains. We switch x's and y's. So remember, this is y is equal to sine x over 5. And so I'm going to switch my x and y and then solve for y. So I switched my x and y. Now I need to get y out of here. How do I get y out of the sine function? I take the sine inverse of both sides. So sine inverse of x is equal to sine inverse sine y over 5. And so sine inverse of x is equal to, these guys cancel, we get y over 5. Multiplying times 5, I get y is 5 sine inverse of x. And remember, y now is the f inverse. So f inverse of x is 5 sine inverse of x, which would be D. That might be a bonus type question on VR. test on your final. All right, a 41 meter guy wire is attached to the top of the 34.6 meter antenna. And it said, so it's attached to the ground over here. And they said the length of this guy is 41 meters. And they want you to find the angle that is made between the guy wire and the ground. All right, and so since this is my theta here, and I've got opposite and hypotenuse, I'm going to use sine theta is equal to opposite over hypotenuse. To get that theta out of there, that's what we're looking for, is this theta value. I'm going to take the inverse, and I get sine inverse of 34.6 divided by 41, which when you put in your calculator, make sure, because these guys are in degrees, they're not giving you a radian answer, they're in degrees. Make sure your document is in degrees, or that you put a degree sign next to your 34.6 divided by 41. The answer should be 57.55 degrees. All right, find an angle theta between 0 and 360 that is coterminal with negative 790. All right, so here we have our quadrants. I'm going to start here. If we're going negative, we're going backwards. So here's negative 360. One more time would be negative 720. And then 720 plus 70 would be about here. So this is negative 790 degrees. So going back the other direction, I want to find something that's coterminal with it. Well, my first instinct was, well, this is how much more. Negative 720 is, or 790 is how much more than twice around, which would be negative 720. And I said, okay, negative 70 degrees, this angle. Which negative 70 degrees is coterminal, and notice they gave it to you here to kind of throw you off. But is negative 70 between 0 and 360? It's not. So we have to keep going one more rotation around. So if I go back this way, I know 70 of this 360 degrees is taken up here. So what's 360 minus the 70 degrees? And that would be 290 degrees. So 290 degrees is coterminal with negative 790, and it's between 0 and 360. So if you're doing this one on the test, take negative 790 and just keep adding 360 to it until you become, so it becomes a positive number between 0 and 360, and that'll get you your coterminal angle. All right, last one, 34. For what values of x in the interval negative 2 pi and pi does the graph of y equals cotangent 2x have a vertical asymptote? So our typical period for cotangent would be pi, but we're taking this period, we're dividing it by 2. So typically, for cotangent, we have our asymptotes at 0 and pi. But we're taking that period and we're cutting it in half, and so we're going to have a period at pi over 2. But they didn't ask me where the first two are. They said, what values in between negative 2 pi and pi do I have an asymptote? So there's one at 0 and pi over 2, and my period's pi over 2. So another pi over 2 would be pi. Another pi over 2 would be 3 pi over 2. Another pi over 2 period would be 2 pi. That's where they want us to end. If I go the other direction, I'm going to subtract off pi over 2. Another pi over 2 would be negative pi. Another pi over 2 would be negative 3 pi over 2. And another one would be negative 2 pi. So that corresponds to answer B. So that is the end of final review A. I'll make the video to review B on Monday, as well as probably review C. I'm going to go help out my Algebra 2 friends who have their final on Tuesday.